Hey all, welcome. Third to last talk, we've got Haydn Johnson who's going to be walking us through Emulate.Go. Thanks a lot for doing this talk, Haydn. It's all yours.
Thank you. Emulate.Go, just to be correct. Hello, everyone. Thank you very much for joining my talk. My face is bright because of this ring of fire in the way. I hope that's going to be okay and not distract me from the talk too much, but let's see how we go. This talk is about Emulate.Go. It's a tool I wrote, and the links are in the bottom left-hand corner if you ever want to play with it. So the way this talk is going to work is I'm going to try a live demo. We'll see if it goes well or not. I have video recordings, but they're a bit too small apparently. So we'll see how it goes. And then each slide that has a good tool or a good link or a good something brain thing is going to have a link in the bottom left corner. So it'll be there. Don't need to take screenshots unless you want to be an influencer, be my guest. So I guess we'll jump into it. And I need to click next slide. So this was a tool or a talk that I previously presented at Red Team Village with Cheerio. She's really awesome. You can find her on Twitter there. Her handle is down below. The idea of the talk was to help CTI analysts contribute to Purple Team exercises, adversarial emulation, all the big win items that you've heard recently. So Cheerio was sharing how to extract indicators, so from a malware sandbox or mostly online sandboxes, because CTI analysts, at least from my experience at the bank, was that I would see a threat report, copy and paste indicators, an IP address into ArcSight, all good, really fun job, into Excel. But CTI analysts generally provide indicators of emulation or indicators of attack to red team people. So we wanted to help them sort of make their job more fun, and two, help them understand the indicators better. So she helped with getting indicators, and then this tool that I'm going to present is going to show how to execute them and sort of extract that a little. So the problem was, or not a problem, depends on your skill level, is that C2 tools can have a steep learning curve. PowerShell Empire, for example, is quite in depth, many modules. C2 tools can require dependencies, so you might need to know Kali Linux or Linux itself. And then you have to do the apt-get, update, install, make sure it has Python, the pip, things like that. And that can be a bit, I guess, it can intimidate, say, someone that's not technical. And then, so that was the problem I was sort of dealing with or trying to fix. The goal was to lower the bar for entry, again, help CTI analysts, anyone who really wanted to understand attacks, students, juniors, stuff like that. I wanted to abstract away the technicality and choose to focus on initial access. So it doesn't do things like privilege escalation, lateral movement, like in interpreter. You get a shell and then there's all those modules, you can inject modules and all the things. Didn't want that. And then the goal was to help people learn. So that was my thought process on this tool. The solution then was Emulate.Go. Oh, someone linked it. Thank you, Ophi. I can only just see through the ring. It was a client-server implementation without a command line interface GUI. By that, I mean it has a command line interface, but it doesn't have a command line interface GUI like Metasploit or PowerShell Empire. It doesn't have payloads or modules. It runs both on Linux and Windows because it's written in Go. I compiled it for Linux and Windows just so the dependencies weren't there. You can also run the Go code itself. And I limited it to command line execution, so focusing on initial access or the start of the attack lifecycle, as they say. And then because it wanted it to be a repeatable process or to tie the results from the indicators run into a tool such as a SIM, I did basic logging into JSON format. I could just do a text file with it, might change it, we'll see. So if you go to the GitHub, there's a README with some videos. There's the Emulate, which is pretty cool, the ELF for Linux. There's the executable, and then there's the Go code. So I'm a hobby codist, so it could do with a lot of improvement, but we'll keep continuing as long as it's like a professional tool. Eh? So the client server portion of it is, when you think of a C2, you think of an admin interface, a command, it gets executed, it lands on the client runs it, then results are sent back. That's great, that's all I wanted. But then I thought, what about lateral movement or acting as a proxy server? So there would be the admin interface. There's a parent which forwards the traffic backwards and forwards. It's just opens 2 sockets, right, and listens. Then it has the child malware, which executes that, sends the results back to the parent, which is another machine, and then sends it back to admin. Pretty simple. So for the visual learners out there, the 3 parts are the admin interface, which runs the admin interface, the parent, which proxies the traffic, and the client, which does all the work. So it's all embedded in that one executable or ELF binary. It's all in the one, which makes it easier to use. So I thought of C2 infrastructure or command and control callbacks, and I was like, I want to make this easy, so I want to make this repeatable. So there's a normal process where on the left screenshot, does my mouse show? Cool. Is that it'll run command by command, you enter it, it gets results back, or you can run a list. So the list is a file, just line by line of the commands you want. Simple as that. So there is a caveat with this, because of the way I have it execute the command, or at least in Windows, is that it does cmd/c, which means it's beacon-like. So /c carries out the command specified by the string and then terminates. So it's important note for this, because when you're using it, you cannot change directory in one line. Like you can't go cd ... up and then execute the next command that directory. It needs to be all in one line, and I'll show that in one of the demos. Another thing I was thinking about was logging, as mentioned before. It outputs to JSON format, the timestamp of command execution, and then the results. So I just wanted a way for an analyst to say, okay, these are the results I got back. Now in Elk, Splunk, maybe an NSM tool, can you how can you more easily find the indicators or events of the log, things like that. And if you run it one day, maybe you want to test it the next day, and then you can just look. And then it prints to the screen unnecessarily because it's a hobby tool, but it prints out so that new users can see, one, that it's running, see that what it's doing on both the client and admin interface. So normally malware on an infected machine isn't going to print and run through it, but this one does. So I thought maybe I'll add a dash silence for that, so it doesn't print anything to the screen. I do need to refactor that a little, I think, because there might be some lines I've missed, and even using silence and something will pop up. So in the idea of making it easy, I was thinking that why not add encryption? So if you add it on an admin server, your infected host or whatnot, and the traffic's going through in production, maybe don't do it in production, but if you have some network monitoring tools, I was thinking that basic encryption might bypass it, so you don't have to disable or whitelist it every time you want to use it. So certificates are normally included on the server, and then it connects like that, and you need the IP address and all that information. However, I didn't want someone to have to do that, so I just self-signed the certificate in a really non-ethical way, or not a good way to do this if it's for prod. But the insecure verify is set to true, so it doesn't verify the cert, it just accepts it, and it still encrypts the traffic. So it's just a way for someone to add TLS if they want, and then you can use Wireshark and see that it's encrypted and non-encrypted, things like that. I think that's all I had. It might help with firewalls. And then another thing with the tool is that it pushes all the options to the screen, again, for easy use, such as logging on or off, running in clear text. And I just added press enter to continue, just so you know what you're doing or can see what it's going to do. So I added dash skip in case you want to make it a repeatable process, and then it won't actually pause. I was just trying to make it easier so someone could see the options, or not if they want. So demo time. I hope you like the tools. I think it's pretty cool. We'll see. So the video I wanted to show was the basic admin and a scheduled task. Come on, VLC, let's run. Oh no, it's slowed down. It's all right. So this should be big enough. Basically, it's a Ubuntu machine. I call it Ubuntu. And then the host name in PowerShell is it's an AWS system in the cloud. And then we're just going to run the ELF. I did accidentally upload the executable. So you just do dash mode for admin or client. So in this one, it's going to be admin. Dash listen and the IP address. So what port is it going to listen to on 888? Because that's what all the elite APTs use. And then you can see the options showing. And then it even tells the user which port and IP address to connect the child to. So on the Windows machine, you run the executable, you use the client mode, you do -client connect, because where is the client connecting to? And then you do the IP address and the 4 ports as well. And then it just simply connects. I was nervous when I was doing this demo, so my typing was a little off, but as you can see, the options run, it's connected, OS identified as Windows, and just 2 commands simply comes back. We called it the domain extra spicy because we were calling our talk spicy emulation or something. The other demo I wanted to show was on the scheduled task. Pop up, please. So the idea here was that Cheerio from the previous talk was reversing malware and getting indicators, and then there was a scheduled task. As such, I just wanted to create an executable that would print to the screen, like on the right here. This program will test the scheduled task, and I wanted to demo the tool doing that. So this is going to do the admin list. It's going to listen on port 44. It's going to use a schedtest.txt and run through that. So again, we're running. TLS is enabled. DSET, yes, that's very true. And then it runs through that way. And then it was just lucky because I set it to the minute that it popped up in a couple of seconds. So it wasn't me cheating, it just was the end of the minute, I guess. And then the results show up. So it's nice and simple like that. Okay. Now the limitations of this tool, again, it's not going to help with pen testing. It's not going to help with dumping credentials. So you can't say module mimikatz, dump LSAS, stuff like that. Might bypass IDS, we'll see. Swapping out the cert for it. Yes, but in the code, it's there. It's just you have to use the actual cert itself, like the actual code, not the file. If that makes sense. So with the talk, I wanted to tie it all together. It was about adversary emulation. So we wanted to extract the indicators of emulation. The idea is to execute those indicators, then review the alerts, logs, and tools, and then fix identified gaps. The whole just attack, defend, figure out what it is, and tune. Same old, right? So I wanted, because this is BSides conference, my talk notes have disappeared. Because it's a BSides conference, it's a local con in Toronto. So I'll stop reading the chat. There's a lot of students, a lot of juniors and entry level here. So hopefully this helps you. If you've already done this, you can just take a coffee, be good. So what I advise as a home lab is a minimum is a Windows client and a Windows server, domain connected and PowerShell logging, especially if you want to do PowerShell stuff, because I just really like PowerShell logging and the script block logging. I find it's really awesome. And then the ideal one is Splunk or Helk and Greylog with Sysmon, your group policy objects, and audit policy, all doing all the threat optics. And the funny thing was the last talk is Cheerio was doing the malware analysis. Live malware has strong VM detection, so you're not going to be able to run live malware in a lab like this unless you use anti-VM detection. So the reason I brought this up is that there are really awesome labs in the cloud which make it really easy to pop it up, pull it down if you don't have the infrastructure at home. So this Terraform is really valuable here. So the one I've been using the most, because I was just introduced to it first, is the Applied Purple Team Lab. It's in Azure from Microsoft. You can have a free trial of $300 or something. It uses Helk. The link's in the bottom left. Whereas the right one is the Splunk attack range, which was also demoed at Red Team Village, which I thought was amazing as well. It's in Amazon, obviously the most popular AWS. It runs Splunk, so it's more of, I guess, an enterprise tool. It's obviously the free version to pop that up. And then it's called the Splunk attack range. It also has OS query and an option to add Kali and an Zeek, I think. Yeah, it's pretty cool. But I tried to create this last week or on the demo, and there were things that were some breaking. I didn't have time to fix it, so there's no demo for that, sorry. So I'm 15 minutes in, perfect. So talking about the home lab, I really wanted to spend time not just showing the tool, but helping students, showing my thought process on how I learn and how I run attacks. And then I found this really valuable because in the process injection training, they were talking through their code examples and talking through it really helped. So hopefully this helps you guys as well. So I called it the one-man purple team, aka you're just going to design an attack, run it yourself. So if we take the purple team exercise framework as a framework to use for this example, there's 4 stages: cyber threat intelligence, preparation, exercise execution, lessons learned, which is great. So for cyber threat intelligence, for exercise design, what attack would you want to do? So let's look at MITRE ATT&CK framework. Everyone knows it. It's really crazy good. So I just found up WMIC as an example. Just quickly grab a technique, T1047. I've seen that Astaroth uses WMIC to execute payloads. AP29 is used WMI to steal credentials and execute backdoors. So this comes in handy. So let's use WMIC to execute a payload. That's a really good idea. So then I was Googling around and I found the living off the land binaries in scripts, or I got it from a friend or Twitter. But the important thing is you search and you learn. And then this website has a bunch of binaries that lives on Microsoft, can build things or do awesome sneaky stuff. So as you can see, it has WMIC, has execution, which is great. That's what we wanted. So what happens when we go in there? It tells us how to execute. It gives us a command, which is pretty awesome, I think. So wmic.exe process call create calc. So we're going to save that for our exercise that we're designing. And then I was like, so we're going to execute something, but what are we going to build? So how can I build something? And then I was like, oh, I found this one, binary file used by .NET to compile C# code, csc.exe, and it's on Windows, which is really cool. And so we have this executable in Windows that will turn a C# file into an executable. It will compile it, which is pretty awesome. More learning. So what do we want to compile here? So we have CSC building something, but if I'm in my organization or at home, I don't want to launch malware. So the cool learning experience was C#. So I wanted to build a defanged executable. It's just going to be hello world. So I Googled it and it prints line hello world, which is awesome. But then we need to get it on the machine through the tool. So we're going to use PowerShell. So this is the command lines I came up with in my tool. We're going to enable TLS 1.2. We're going to use PowerShell invoke web request to download the file that I'm hosting on GitHub. It doesn't have to be stealthy. Then we're going to use the CSC executable to build it into what we call test.exe. And then we're going to use WMIC to execute it, which is pretty cool. I added another screenshot here because this was it. The way, remember when I mentioned that the way it executes CMD, that you have to do it in a one line? So this top bit here is all a one-liner because it runs in CMD. If you run this bit in PowerShell, it won't work. So CMD just enables TLS, then PowerShell allows it to be downloaded, then the rest executes. That's great. So what do we have so far? We have an attack scenario designed and payload to use, which is pretty awesome. So now to preparation. Back to the framework, it's the next step. Preparation for an org is more like what team does what, who's the white team, what's the CTI analyst researching, what attacks are going to be executed. But preparation for me, in this, on your own, in a one-man purple team, is setting up a lab and getting the threat optics bouquet. So preparation, lab setup. So for this demo, I'm going to use the Applied Purple Team Lab. It's in Microsoft Azure. I'm 20 minutes in, so I'll try to hurry this up. You just setting up the lab, you download the Terraform script, you run labbuilder.py after you've added the subscription ID and all the access it needs. Then it runs for 20 minutes, and then you go get a coffee, which is great. It sets it up, domain, client server domain, and help. So when it finishes, you'll see your Stu public IP address here, and then Stu client, Stu DC, and Linux. What I advise is adding a public IP address for Kibana because it's so much easier than having to remote desktop in, load the terrible Internet Explorer up, and then off you go. But there is also enabling threat optics, which includes sysmon, audit policy, PowerShell logging. So the guys from Defensive Origin have created this, which is amazing. It pulls different zip files. But when I was testing it, it wasn't consistently grabbing PowerShell logs. So myself, I just pulled the repo and then added through PowerShell manually. It just gave me confidence that it was logging what I needed. And ironically, today it wasn't giving me the full logs. So funny things can go wrong. So once it's built, you have your PowerShell here. It says computer policy update. You run it on the Windows and the server, but server first. Then to the right in your Kibana, you'll see host name. So I would always double check that you're getting logs from both, because it's important to compare both logs at both machines, both logs, yeah. So the lab so far is we have an attack designed with payloads. We have the threat optics lab set up and all the logs logging. So now we get to the fun bit. Well, it's all fun for the exercise for the 20 minutes. Awesome. So again, the purple team exercise framework, exercising the execution or exercise execution. Now I have a YouTube, it's recorded, which is awesome. But what I wanted to show was live. So let me grab it and see how the demo goes go today. So if I just type, what I've done is I've taken the commands that we spoke about earlier and I put them in the file commands.txt, which is awesome. And then with my tool, I'm just going to do dash mode, admin list on all interfaces on port 88 with the commands.txt. Then on my server, again, if I clear it, there really is nothing here. Oh, there is a hello world. Let's remove that because I was testing. It's all prepared before. And if we go here, client connect IP address, we connect, and I press enter, it runs, and bada bing, bada boom, you have execution, which is pretty awesome. And as you can see, like I said, the client or the child malware gives a lot of screen printing so you can know what's happening. But the important thing is that we got our hello world and then we had WMIC here, which is pretty cool. And then I think, oh, the cat somehow opened my door. That's great. But yeah, it downloaded the C# file and test.exe. I wonder if someone closed the door for me. Nice. So from that, you've run the exercise, the C# file, which is really good, and you followed your design. So then the fourth part is lessons learned. So when I go through the execution and design, it's all good, but what do I want to learn from it? I've learned how to build C#, use PowerShell to pull it down in the attack. But from a pen testing point of view, what logs am I creating? Or from a defender, what logs is being created and how can I tune them or find them? So this is sort of a contrived example with like 10 minutes left. So I will go, oh, nope, let me fire up this one. I had this prepared earlier, had them all in tabs because it was running slow. Oh no, a good one. So for example, I would type hello world. Not hello, just hello with asterisks. As you can see, I've tried other queries. And the methodology is that you search through, you have a look at the event ID 4103. Ooh, PowerShell, awesome. And then you can just view what different bits are there, what fields are in the logs, which is pretty cool. But one trick I wanted to show when I'm looking through them is that I try to list the event IDs that are triggered, because you can get probably thousands of events, but if you're in your lab, you're generally fine. So you can see here, there's 600, I think, related to PowerShell, and one is process creation, 400, 4103, and 11. I think no 3, isn't it? Anyhow. So you go, oh, nice, event ID 1. So let's do event ID 1, and then hello, stuff like that. And what that brings up is your hello world C# file and your event ID. Where is the other one? Event ID 1. What this allows you to do is really understand each log that's created, which machine it's on, where it's being executed, stuff like that. So what else I wanted to show was that if you type in csc.exe, it'll bring up the process name. So like here, no, that's wrong. You can see the process name and you can say, okay, so event ID 1, which was showing up with hello when we were searching, hello was coming up there. Here, look, it comes up, it shows csc.exe, which is pretty cool. And then within ALK, I might, it might not move too quickly. We shall see. Nah, it's running real slow. Anyhow, I would save it as a search and like you can learn through hunting and whatnot. So for WMIC, it's the same kind of methodology. I've got 10 minutes. Awesome. So WMIC, you can see it launched here. I don't know if this is the right log. This is live. So there's not too much information. So that's not that useful. But if then we go down to the next one, we can see that the process command line, thanks to sysmon, is WMIC. So would the process command name be? No, we understand the parent is PowerShell, which is then launching WMIC. So that's why in the next one, I would search process_name equals WMIC.exe, and then the process command line process call create. And what I've done within ALK is list the columns, parent process command line, and the process name. So it's much easier to sort of see what the log has, or at least the vital pieces of information, such as this command line. Because if you drop down and you go to here, raw event or something, or if I just delete them, okay, I've got an error, fuck it. Can I close that? Oh, excuse my language, sorry. Damn white's in the way. Anyhow, as you can see here, is that it's not as clear to read that. The columns are really important, which is pretty cool. And from there, I wanted to show this little, not trick, but I love PowerShell logging. So the idea here was that event ID 4103 script blocking would show everything that was executed. Now, this is the problem with Windows logging or your lab. You might not have all the logs you expect, so you might not have it in prod, stuff like that. So here you can see my PowerShell is launching the C# file and then the out file, which is pretty cool. But the video I wanted to show is here, down to the end. Yeah, so in this log, as you can see with the PowerShell parameter value, is that it's a huge, it shows everything I did in the one file. So it's really awesome to look at different things like that, which I think is valuable. I think I've got 12 minutes. So hope you liked the demo. It's just sort of my methodology of trying an attack, or sorry, finding an attack sounding interesting, building it, trying to understand what payloads you might use, running it in a lab, and seeing what events it logs. And it's a contrived example as well, because obviously in real life, you're going to have a lot of different logs. You might have a lot of false positives. Anyhow, I'll get to that. So we understood an attack, we understood the execution of the attack, and the payload we built, which was awesome. And then learning from that, we learned how to build a basic C# program to execute. We reviewed the logs and considered different things within the logs, which is awesome. So the tips for detection, as I said in the demo, is that to list all event IDs or logs related to the indicator. Might not be for Linux, I'm not so professional with that, but they don't come up as clear. But it's great for Windows. You list your event IDs from there, and then you can choose what you know. So if you've scripted hello world like I did, you can look for that as an indicator. And then you can look at all of the logs and sort of see what are valuable, what are not. And so continuing along that is that you should probably review each log, understand what each log means. So sometimes they have the same event ID, but it might be PowerShell or something else. I found that sometimes confusing. And then what fields are valuable, whether it's a process name or if it's just like a random string. And then again, consider events from both hosts. And then there was another one from work we've been working, it's not anything famous, learning about is alert logic. So you might have like CSC building something on customer support, who cares, whatever, it's a medium event, hypothetically. But if something's built or malware is detected on a prod surfer with health, you might make that critical, right? So when it comes through, it pages everyone, just like that, simple. And then I've also added the links to sysmon and some of the links that I search for events. Now, to go back to students and juniors or entry into the field, because my friend and I are in the DC41 Slack. We do a lot of resume, ATDT. Shout out to you, bud. We review their resumes, and I wanted to add this little bit. So what have you done? You've done understand the attacker lifecycle, PowerShell commands, Windows logs, and sysmon. So what can you tell your hiring manager? You might word it as, I have executed different types of attacks. But what does that mean? It's more like, I have an awareness of the attack lifecycle and various attacks that can be used, and sort of have a better understanding of how difficult or easy they may be to launch. What Defender might block it, and you're like, oh, now I need to disable Defender. Or then what I found out with testing was I need .NET on the machine. So if it's just popped up in the cloud, it's not going to have any development frameworks, and then I'm SOL. And then I have an understanding of different Windows logs and have played with them for detection. So I think that's really important. You don't necessarily need to know that 4103 is PowerShell script logging, but some more in-depth logs you might like, or just an awareness of sort of the information and what it is. So if you're wanting to do this on your own, definitely use the Cloud Labs. But if you're stumped for ideas, because I like working from an exercise point of view, goal orientated. When I do training course and it has like 100 PDF and I've got to read that before I get to the labs, oh, it's like pulling teeth out. So I found this one, it's free. It's from Cyber Must Say Security. It's free curriculum. It's Australian, which is awesome. So it has about 80, 60 different exercises. So there's one such as write a PowerShell script to list missing patches, which then you learn about sort of people's code they've written, how they do it, and you sort of use parts of it, which is pretty cool. The write an application vulnerable to cross-site scripting, I haven't done, but I might do it out of interest. And then my favorite, or at least like for this talk, was write elk filters that detects simple attacks. So I've got 8 minutes, I should be good. So in this one, as an example, it just says PowerShell encoded commands. You want to detect, how do you detect that? The process mimikatz.exe was started. Gets a little bit harder because everyone loves Mimikatz. And then in the logs, like a process other than Explorer launches PowerShell.exe or CMD. So again, in Elk, I showed like the process name. You could just do not Explorer.exe and process equals PowerShell.exe. And then the bottom right, they have references. So I definitely have the link in the bottom left, which is pretty cool. So you should have a takeaway for that. In all summary, the tool that I've built can really help simplify executing the commands. The labs help in building detection and understanding the attacks, but the real value comes from yourself setting it up, running into errors, because that's always fun and a struggle, but you learn the most that way. So hopefully that gives you a methodology and a process sort of to help you guide learning on both attack and defense. So I think I finished 7 minutes early. I kind of speed run that a little by accident. My contact details are here, the tool is there, and I guess anyone to pop up any questions.
Thanks a lot. Now I understand the Sriracha shirt.
Yes, well, yes, for spicy emulation, and because the BSides Toronto logo was red.
Absolutely.
Yeah.
So there haven't been any questions that have come in yet. But thank you for putting in all this work to create this Emulate.Go. Seems very useful. Set up that environment quickly, give people that platform to work on.
The lab, I should probably differentiate that the lab environments in the cloud are not written by me. They're written by 10 times smarter people and 2 groups of people. So it was just my tool being used in that lab. So I cheated a little.
No, it's all good. All right, well, if you want to do more live demos, you have time. Otherwise, I
can just show. So when I was setting up the Purple Wind lab today, there was some errors. It was building fine, as you can see, but it still errored in that. Oh my God, I scrolled up like a million times. Is that there was an error joining the domain. So if you do run into this, I would suggest you can just go into Windows yourself and connect it to the labs.local domain. So, and then it was all working. It was just, I was missing some logs on the Windows for some reason, or the client. So that's why I did it a little bit differently, but there are issues, but you can work through them.
Fantastic. Thanks for that. All right, well, with that, we'll end the presentation. Thank you very much, Haydn, for coming and talking again at BSides Toronto.
No worries. Thanks for having me again.